Here we go. Okay, to figure out if the pattern is quadratic, linear, or exponential, you got to figure out how fast it's changing. 32 to 12 is going down 20. This is going down 8. This turns around and goes up 4. This turns and goes up 16. And then up, what's this, 28? And then up 40. Okay, it's not linear because it's not changing the same every single time. So I'm going to go again. And then I notice that's going up 12. That's going up 12. That's going up. So by definition, this has to be a quadratic because my second change is constant. If it's quadratic, I know the explicit function has to follow this form. ax squared plus bx plus c. Every single quadratic follows this form. A, b, and c are what I've got to find. If I can find a, b, and c, then I'm done. I know a comes from that constant change. A is going to be 12 divided by 2, so I know A is 6. C comes from your table, and it is going to be your y-intercept. So C is going to be 4. So now I got to choose an x and a y, and do not choose 0, 4, because that will make you sit and spin your wheels. So I'm going to go with this guy right here. I'm going to choose 1 and 8. I'm going to choose 1 and 8 for my x and for my y. Now I'm going to take everything and substitute it into this grandfather equation. I'm going to replace a with 6. I'm going to replace c with 4, x with 1, and 8 is going to go in for y. So it's going to be 8 equals 6 times 1 squared plus b. Leave it as a variable. You don't know what b is. And there we go. Now just do the algebra. 8 equals 1 squared is 1. 1 times 6 is going to be 6. b times 1 is b plus 4. I can combine these like terms. 8 equals 10 plus b. What number plus 10 is 8? b has got to be a negative 2. So b has got to be a negative 2. So then my explicit function is going to be f of x equals 6x squared minus 2x plus 4. And to double check it, if you punch this in on your calculator and you look at the table and it gives you this exact table, then you know 100% you're right. Okay, the recursive, we have not done recursive for a long time. Okay, the recursive, the explicit function will give you the answer. If you plug in 3 to these x's, it will spit out a 52. If you plug in 4 to these x's, it will spit out a 92. So the explicit function gives you the exact answer at any given x. But the recursive, all we want the recursive to do is explain how much you add. So look, if I want the answer at 3 for the recursive, all I want to know, I do not want to know the answer is 52. I want to know that I'm going to take the one before it and I'm going to add 28. This is all I want to know. I want to know how much you've got to add to it. So I don't care that the answer is 52. All I want to know is I'm going to add 28 to the answer of 2, which is 24. 24 plus 28. So to get the answer at 3, I look at the answer of the one before, 3 minus 1, and I add 28. To get the answer at 2, I look at the answer of 1 and how much do I add to it, to 8, I'm going to add 16. Okay, now I got to explain these numbers because they're changing every time. I add 28, I add 16. So here we go. 28 and 16 come from this right here. 28 is actually 2 times 12 plus 4. 16 is actually 1 times 12 plus 4. So why am I times them by 12? Because 12 is your constant change. You are always going to times by 12. Always by 12. So let's look at the next one. To get the answer at 4, I look at the answer, the one before. So I look at the answer 3, which is 52, and I add 40. But where is 40 coming from? Why is it 40? Because you take this number right here, 3, and I times it by 12, and that's 36. But 36 is too low. I want to get to 40, so I'm going to plus 4. So, to get the answer at any x, you look at the answer of the one before it, and you're going to have to add something. And you're always going to have to add something to do with that 12. So in this case, I'm adding 28, 16, and 40. And I am multiplying by 12 every time. But what number am I multiplying by 12? You're not multiplying. On the third one, I am not multiplying 3 to 12. And on the second one, I'm not multiplying 2 to 12. I am multiplying the one before times 12 plus 4. This right here is your recursive. Okay, this one. This next one is going down 6, down 6, down 6. Okay, this one's easy. This one is linear because it's changing at a constant rate. So linear, every linear equation follows the grandfather equation y equals mx plus b. So all you've got to do, instead of finding a, b, and c, all you got to do is find m and b. M is -6. B, M is your change. Oh, nice eye. Is it really -6? It appears to be -6, but this is a trick question because these go down 6 every time. But look at these guys over here on the left. What's happening here? These are going up. They're skipping. Anytime they skip, it's a trick question. So how much is it really changing every time? It's not really going down 6. It's actually going down 3. Because m is your slope. Slope is your rise over your run. Or it's your y sub 2 minus y sub 1 divided by x sub 2 minus x. You've got to put your y's on top and your x's on bottom. So if your y's are changing down 6 every time your x's change up 2, you got to do -6 over 2. So your slope's actually -3. Okay, your b. Where's your b? It's the same as your quadratic. The b is going to be the mate of 0. B is going to be 4. So your equation, your function is going to be f of x equals -3x plus 4. We practiced choose a pair of numbers. If you choose a pair, I know 2. If I plug in 2, it's got to give me a -2 out. So you take your change, and that is always what you times by. So I'm going to times by a -3. So if I take 2 and I multiply it by a -3, I get a -6. But I know I want my answer to be a -2. So I've got to adjust it. Negative 6. If I plus 4 to a negative 6, it's going to take me to a negative 2. So let's try it with another pair. What is 6 times by a negative 3? You're at negative 18. Is negative 18 plus 4 really going to end you up at negative 14? It does. So that is your rule. Okay, the recursive. The only hard recursive is those quadratics. The linear recursive is pretty slick. So to get the answer at any x, you look at the one before and how is it changing. All you do to the one before is minus 3. Every single time it stays the same. Minus 3, minus 3, minus 3, minus 3. The quadratics are hard because the number that you add or minus changes every single time. But on linear ones it doesn't change, it stays the same. Okay, this one right here. This one is going to be exponential because as it grows, it does not grow by addition. This grows by multiplication, times by 2, times by 2, times by 2, times by 2. To get to the next output, you multiply by 2. Times by 2. If it grows by multiplication or if it shrinks by division, it is exponential. Exponential functions grow the very fastest. So what's going to be my explicit function? How does 3 change to a 8? And how does 2 change to a 4? So if it's just repeated multiplication, look at this. 2, 2 times 2, 2 times 2 times 2, 2 times 2 times 2 times 2. This is 1, this is 4, this is 8, this is 16. So this is 2 to the 1, this is 2 squared, this is 2 cubed, this is 2 to the 4th. So your explicit function is going to be 2 to the x. The number that you are repeatedly multiplying by, that's going to be my base. And my exponent is going to be the x. So if I plug in a 3, 2 to the 3rd, is that going to give me an 8? Is 2 to the 4th going to give me 16? Okay, your recursive. Is going to be, to get the answer at any input, you look at the previous output and how does it changing? What do you do to it? So if I want the answer at 3, I look at the answer of 2 and all I do is double it, times it by 2. So to get the next answer, all you do is look at the answer before and you times it by 2. Check, make sure you got them right. So if you're looking at graphs, a linear graph will look like something that changes at the same pace. It's got to be a straight line. The steeper the line means it changes at a faster rate. If you have a horizontal line, that means it's not changing at all, it's just staying put. So linear has got to be straight. Quadratic and exponential, quadratic and exponential are very similar. Quadratic starts off slow and then it has to be curved because each time it's changing at an increasing rate. Okay, the exponential is very similar to the quadratic. The quadratic actually is symmetrical. It has a point at the dead center where it turns around and starts to go the other way. Because if you think of this, if you think of x squared, if I plug 2 in, it gives me a 4. So if I go over 2 up 4, but if I plug the negative 2 in, it still gives me a negative 4. Or it still gives me the same answer, 4. So any dot you have here, you're going to have a corresponding dot over here. And this takes shape of a parabola. But an exponential is similar in that it's curved, but it, kind of like your tortoise in your hair, it's going to start off slow, but it is going to gain extremely fast. So exponential graphs are going to be much steeper than your quadratic, because look at this one's a bad one, but they gain really quick. Your outputs grow. If every time you're doubling or tripling or quadrupling, these are going to grow much, much faster than quadratics. Okay, rates of change. So you got to look at your table. These are going up 1, while these change up 3, up 3. So your change is going to be 3 over 1. Just 3. Here you got to find 2 dots. This is a linear. Go over and up. Rise over run. This is a positive line, and you have to go 1, 2, 3. You go up 4 over 1. So it's going to be 4 over 1. Okay, this one right here is good. If the x is 0, the y is 7. Now, this, if I put a 0 in here, it says the answer at 0 plus 1, so the answer at the next one, the answer at 1, is the answer of 0 plus 5. So what's going to go next? 7, take that answer, plus 5. What's 7 plus 5? 12. So it's growing. If I want to get the answer of 2, I look at the answer plus 5. So 5 is your rate of change. Okay, this guy right here, 21. If you have a negative 4, your answer is 24. And if you have 6, your answer is negative 36. So how much changed from a negative 4 to a positive 6? That went up 10. How much changed from 24 to negative 36? That went down 60. So if your y's are going down 60 every time your x's go up 10, what's your slope? What's your change? Negative 60 over 10. Negative 6. Every time it's going down 6. 19 is the exact same thing. Negative 3 gives you a 12. Negative 11 gives you negative 16. Do it the exact same way we did right here. Okay, let's go over. Oh, not much. Yeah. Alright, here we go. Day, and this is number of fish. So day 1 he sees 2 fish. Day 2 he sees 4 fish. Day 3 he sees 6 fish. Day 4 he sees 8 fish. Day 5 he sees 10 fish. So this is a linear. So the model that will predict how many fish he's gonna spot on day 28, I see that every day he sees 2 more fish. So this is a linear, nice and easy. I know I'm going to times by 2, and now I'm going to pick a pair, and I'm going to experiment. 3 times by 2 is 6. I do not need to adjust. I don't need to add anything or subtract anything. 4 times 2 is 8, so we're good. So I'm predicting that day 28 times by 2 is going to be 56. So my explicit function is going to be the number of fish equal the day times 2. Okay, now the model that's going to predict the total amount of fish, this is going to be a little bit different. So day 1 he's going to see 2, but day 2 he's going to see 6. because 4 plus 2. Day 3 he's gonna see 12. Day 4 he's gonna see 12 plus 8, that's 20. One more. Day 5 he's gonna see 20 plus 10, that's 30. So see how fast this is changing. 2 to 4, or 2 to 6 is plus 4, 6 to 12 is plus 6, 12 to 20 is plus 8, plus 10, plus 2, plus... Okay, now I know it's a quadratic. If I know it's a quadratic, I'm going to find this. I'm going to use this model, ax squared plus bx plus c. I got to find a, which is the constant change divided by 2. So a is going to be 1. B, I don't know. C is going to be 0, because on day 0 he does not see any fish. So I'm going to now pick a pair. I'm going to pick 1 and 2. Pick 1 and 2. 1 is your x, 2 is your y. And start subbing in. Sub the y there, the x there, the x there, the a there, the c there. So 2 equals 1 times 1 squared plus b times 1 plus c. So 2 equals 1 plus b. So b must be 1. So now a is 1, b is 1, c is 0, y equals 1x squared plus 1x. That will predict how many days, how many fish he sees on day 28. So if I plug a 28 in there and a 28 in there, and I do the arithmetic, it will tell me the total number of fish that he has seen. Alright. These guys, 16, I'm going to do 16 down here. We'll probably just do 2 of them. No, put that back. Okay. X, Y. If I plug in 0, it gives me a negative 5. But now let's see what this, let's see if I can interpret this. To get, if I put 0 here, to get the next one, I look at the one before it, and I add 8. So negative 5 plus 8 is going to be 3. So I'm going to plus 8. 2 is going to be 11. Plus 8. 3 is going to be 19. And just keep going on and going on. Let's do 19. Let's look at this guy. X, Y, okay, they give you the first 0, gives you 6 for an answer. Now to get the next one, to get the answer of 1, I multiply the answer by 2. So 6 times 2, that's going to be 12. To get the next one, I times 2 is going to be 24. To get the next one, I times by 2 is 48. Okay. Last one. If you got 600 feet of fence, that's all you got to use. They want you to fill out the table. So this is width. If you are using 50 of it here, you have to use 50 of it here. So you have used a total of 100. If you have a 600 and you have used 100, you only have 500 left. But you need to divide that by 2, and that gives you 250 on top, 250 on top. So if you add 250, 250, 500 plus 50 plus 50, you have used a total of 600. So this has got to be 250. 0. If you use 0 on the width, then that means you have 600 left. So you use 300 here, 300 here. Let's do one more. 100, then you can fill the rest of the table out. If you use 100 for the width, that means you've used 100 on this side and 100 on this side. You have used 100 plus 100. You have used 200. This is move number 1. Move number 2, I'm going to take the total minus how much I've used, and that gives me how much is left over. Move number 3, I'm going to take how much left over, and I'm going to divide that by 2, and that tells me I have got 200 to use for the top and the bottom. So now B, what if you use width as x? Just follow these steps. Move number 1, I'm going to do x plus x because you're using x on the left and x on the right. So I'm at a total of 2x. Move number 2, you're going to take the total, which is 600, and you're going to subtract what you've used, 2x, and 600 subtract 2x is just 600 minus 2x. Move number 3, you are going to take that and you are going to cut it in half. So, and I can actually cut both these in half. I can simplify that to 300 minus x. So the rule to find the width, I just take 300, or this will give me not the width, this will give me the length. I take 300 minus the width, and let's see if that is accurate. So here is my width right here. To find the length, can I just do 300 minus the width? 300 minus 100 is 200. Is that the length? Yes. Is 300 minus 50 the length? Yes. So that works.